All right, this is Chapter 2, Section 3, Part 1, Product and Quotient Rules and Higher Order Derivatives. So we're going to start off with the product rule. The product rule, if I'm multiplying two differentiable functions together to get the derivative, I take the first function times the derivative of the second, plus the second function times the derivative of the first. So let's see that in action. But first, actually, we could extend this to three functions. I take the derivative of the first times the second two unchanged, plus the derivative of the second times the first and last unchanged, plus the derivative of the last times the first two unchanged. So to do that, the derivative of f of x equals x squared times sine of x times cosine of x. My first piece is x squared, my second is sine, my third is cosine. So I take f prime of x equals the derivative of the first part. So the derivative of x squared is 2x times the second and third parts unchanged. So sine of x, cosine of x. Plus the derivative of the second part, the derivative of sine is cosine of x. First part unchanged, last part unchanged. Plus, I ran out of space there, derivative of the third part, which is negative sine of x, times the first two parts unchanged, which is x squared sine of x. And now I just simplify a little bit. So f prime of x equals 2x sine x cosine x plus x squared cosine squared of x minus x squared sine squared of x. And there's my derivative. So let's find the derivative of h of x equals all this craziness. First way is by using the product rule. The product rule says that I have h prime of x equals the derivative of the first part, which is 3 minus 4x times the second part unchanged, plus the first part unchanged times the derivative of the second part, which is just 4. Then we would clean this up a little bit. Let's FOIL out this first part. So I get 15 plus 12x minus 20x minus 16x squared. And distribute the 4 here, so I have 12x minus 8x squared. Combine all my like terms, and I end up with negative 24x squared plus 4x plus 15. The other way says by first multiplying. So what I'm going to do is I'm going to FOIL the original function before I do the derivative. So just h of x. So when I FOIL, I get 15x plus 12x squared minus 10x squared minus 8x cubed. Clean that up a little bit, and h of x is negative 8x cubed plus 2x squared plus 15x. Now I take the derivative. So I use the power rule, so I get negative 24x squared plus 4x plus 15. Now sometimes it might be nicer to do it this way. Sometimes multiplying it out isn't really an option. It all depends on the problem. Oops, I skipped one here. There we go. Now I need the derivative of 3x squared sine of x. We have two things multiplied together, so we need to use the product rule. Y prime equals derivative of the first part, which is 3x squared, so that'll be 6x, times the second part unchanged, plus the first part unchanged, times the derivative of the second part. The derivative of sine of x is cosine of x. And there's no cleaning up necessary. There's nothing I can do. That's my answer. All right, this one is going to use the product rule and adding and subtracting rules. So we'll start with product rule here. Y prime equals first part, second part. So the derivative of 2x is 2 times the cosine of x plus 2x times the derivative of cosine is negative sine of x minus the derivative of 2 sine of x is 2 cosine of x. Look at this. 2 cosine of x minus 2 cosine of x cancels, leaving me y prime equals negative 2x sine of x. So now you're going to try some product rule problems.